So, hello to those who are not here. I've got a little bit of contention in the class because I'm saying I've changed my mind and I feel like I want to add a question like this into your test on the very next lesson, even though you have a whole weekend to play around. And this is from your outline, and people are going blah, 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 blah at me, and I can feel the daggers in my back, so I'm not turning my back to the class. But all this is saying is, let's imagine that we had, so as an example, what if we had y equals, so p is like a number for now. So let's go with, pick a number, any number. Yeah, see, why would you go big? I've gone 4. E, no, now we can't go 5 because notice it's p and it is p. So if it's 4e, it has to be 4e to the 4x. Okay, so if I ask you to now differentiate this, what would you tell me the derivative is? So we're going to go dy by, hang on, dy by dx equals, and I'm going to do this for a reason, 4 times, it'll be 4e to the 4x. Do we agree? Okay, so then I'm asking you to differentiate again. D second derivative. And this would be basically n to the 1. This will be n to the 2. So what is my second derivative? It would be 4 times 4 times 4e. Like I could 4e to, I could times it all together, and you know, I know 4 4s are 16, and I know that 4 times 4 times 4, but I also would like to think that you had a little bit of a look at this. And so when we look at this, you're saying that this is 4 squared. And when you look at this, you would say this is 4 cubed. And so if I was to say, what conjecture would you make for this? Would you then say that your conjecture would be, if it was the nth derivative, what would you say it would be? So now, before you say, have a look. When n is 2, this is what we got. When n was 1, this is what we got. So now we're saying when n, oh dear me, when n is n, bless you, what do you think that we will get? Right, it will be 4n plus 1, because when this was 2, this was 3, so we've increased it by 1, and it's e, it's the same thing, correct? To the 4x. So your conjecture is that's how they've got this thing here. Would you agree? So now, can we use induction to prove it? Yeah, now you're going, what, before we even try. Some of you are going, yes, 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 yes. But the ones of us who are going, well, let's just, So what do our induction things say? We're going to, so this is now your end statement. Do we agree? So we are going to assume what? We agree we've proved P1? Yep. So if I whack 1 in here, 1 plus 1 is 2, so I get 4 squared, e to the, so we could do it nicely and go, yeah, P1 is proved. And we're going now to assume PK is true. So what are we actually assuming? Yeah? So the question was, are we using 4 or are we using P? So this is prove the derivative, for example. So I could put P in there. I could put 4. I could put 6. I could put 2. I could put 10. I might put X. Well, we'll see. I was thinking, and then I thought this is actually a really good one because it leads into conjectures and ticks that box, because you have to pass a conjecture question. So why not? It's an easy one, I reckon. So assume pk true. So what are we doing? Wherever n is, we just replace it with k. So therefore what we're doing is we're trying to prove, or we're assuming the kth derivative will be 4 to the k plus 1 times e to the 4x. So far, is this quite nice? Okay. And I really like it because it's now making you just go back and reinforce your induction process. And then what do we have to do? To prove, yep. So we want to prove k plus 1. So what does that mean? We want to prove the k plus first derivative. What will that be? That'll be 4 to the k plus 2 e to the 4k. So far, so good. So how are we meant to prove that? Triage. Using pk. Don't any of you just write triage in the test, please. You have to write using pk. Maybe in brackets you could put triage. So we have to now take this thing here and we're going to differentiate it, aren't we? So we're going to take our kth derivative, we're going to differentiate it, and we're going to hopefully prove that it will equal this. Do we agree? So probably the hardest thing is your notation, I guess. So I guess you could say if we differentiate, so if we differentiate 4k plus 1 e to the 4x, you could write differentiate it, it doesn't really matter. So what is the derivative of this yellow thing? Sorry, I'll pop it up higher for those at the back. So again, that derivative stuff just gets in the way of life. So what is the derivative of this? No. Right, so this is like a constant here and you're multiplying. It's not a function times a function, right? So it's 4k plus 1 and then we're timesing it by 4 e to the x. And so what is this? Oh my goodness, that's 4k plus 1 because that's to the 1. Do we agree? 4k plus 2. And that equals k plus 1. Does it not? Oh, 4. I left the 4. I forgot the 4. I forgot the 4. I forgot the 4. Yeah, bang, done. Therefore, true. Now that our p's are not the same, what happens? I'm saying this is our rule. So can we prove that that's true? So what do we do first? And we'll go n, let's go n is greater than 1. So first thing we have to do, right, you've got to prove P1. So how do we prove P1? Well, we have to take y equals 7 e to the 2x and we have to differentiate it. What is the derivative of that? 7 times 2e to the 2x. Yeah, notice I'm not going to go 7 times 2 is 14 because look at what I'm trying to prove. Now, if I take this statement, this is d1y dx to the 1 equals 7 times 2 to the 1 e to the 2x. And doesn't that equal that thing there? True. We say therefore P1 true. Do we agree? What's the silence saying? Yes, we're happy, or no, we're not? All right. Onward. Assume PK true. So my stance is that this is no work, this is substituting. So notice that it's not k plus 1, it's just k. Because I changed the constant out the front. And we want to prove so we're trying to prove the k plus first derivative will be 7 times 2 to the k plus 1 e to the 2x. So no maths, just substituting. I guess you could say substituting is maths. Here we go. What you have to do is you want to look at this. Right, that's your kth derivative. If you differentiate that, then you get your k plus first derivative. And hopefully you're going to prove that it equals this. Okay? So here comes the proof. We are going to differentiate. If you don't like all this, you could say let that one be, well, I guess we can't say let it be y. Yeah, bad luck. So, f of x, true. Yes, you could call it f of x. Yeah, I'm just going to stick with the notation. I'm going to say that if I differentiate, actually, here we go. We could say dk plus y over dx k plus y, that will equal the derivative of 7 times 2k. Stop talking while you're right next to me, boys. It's all right. I forgive you. They're so cute. So here we go. And all that you're having to remember is that this is a constant. So we write the constant and then we multiply it by the derivative of e to the 2x, which is 2e to the 2x. Hello. Our work is done. That's 7 times 2 to the k plus 1. Therefore, pk plus 1 is true. Oops, using pk. And ish. Hang on. So for those playing at home, the questions were, what? Why have we got all these n's? Where is n even in our statement? Well, it's here. Okay? So we go, don't really know what's going on. Some of you do, but the rest of us are going, So first thing we want to do is we want to prove P1. I'm tempted to say, oh, actually, do you know what? Let's go this. Oh, why? Because I'm just messing with you. Because I'm trying to show you, you're not going to have exactly the same questions that you're used to. You want to try and have an unfamiliar question. So this could be a gold mine. Ready? So here we go. When it's saying P2, what is that asking you to do? Find the second derivative. Exactly. So let's start with, in order to find the second derivative, you first have to find the first derivative. So here we go. And this is the bit where I go, some of you will take more time than is necessary. So your quotient rule, may I remind you, quotient rule, your product rule is differentiate the first function, keep the second function, plus keep the first function times by the derivative of the second function. So I just go, holy moly, I go, here's my first function here, this is my second function here. So let's hit it. What is the derivative of x squared? 2x times your second function, e to the x. What's your first function? X squared. What's the derivative of your second function? E to the x. Bang. Some of you are still writing u, v, and filling it in. Kills me. Yeah, would you like to take a common factor out? Doesn't really matter. Let's do it. Yep. I mean, if you didn't take a common factor out, you're just doing the product rule twice. But if we can take our common factor of e to the x out, we've got 2 to the x. X, e to the x. Ooh. No, I'm going to go 2x plus x squared. Can anyone tell me why? If I pulled out x e to the x, That's a function times a function. Then I've got more headaches. So if I can just pull out e to the x, that's going to be nice, one hopes. Ready? So again, if you want to write this around the other way, so it's similar to the question you did before, then do it. Do you want to do that? I'll keep going. Okay, so what does our, like I would have actually written this, I would have rewritten this and gone 2x plus x squared times e to the x, just so it is like that first one, because I'm in the groove. But I've been told, no, just keep going with this one. So away we go. So, no, it doesn't matter. Like we're just doing, I'm just saying you guys are complaining that it's something different. But here we go. So I'm using my function rule. I'm looking at this. So what does it say? Here's my first function. And, you know, rock your colors. There you go. There's your second function there. What is the derivative of e to the x? E to the x. What does the product rule say? Just times the second function. Don't touch it. Then put a plus. Write your first function, and we have to then multiply it by the derivative of the second function. So what is the derivative? 2. I mean, that's really hurting my head a little bit, isn't it? I'm stopping. Wasn't recording. Sorry. Wasn't recording. Missed that. So, oops, made a little bit of a whoopsie. Sorry, G. Sorry, Orjit. Sorry, Ryan. Then what I want you to do is look at this, find your PK, write down what your k plus 1 is going to be, because that's all you're doing is wherever n is, you're replacing it with k and then k plus 1. Let's do it. So all I have done is wherever the n is, I've just replaced it with k for this one, and then I've just replaced it with k plus 1 for this one. So here comes the proof. So I have to go back to my k derivative, and I'm going to differentiate that to get my k plus first derivative. So the k plus first derivative is going to be the derivative of, and you know, if you've got one of those gel ink pens, you are wasting a lot of ink, but geez, it looks impressive. By dx. E to the x. Thank you. Maybe get a highlighter, get a different color pen, or whatever, but that is your first function. That is your second function, and here we go. I'm not even looking at the e to the x, I'm just looking inside, and in my mind, when I'm looking at k, I see a number, like 5. So what is the derivative of a number? 0, so that's no derivative there. What is the derivative of 2kx, or like 5x? What would it just be? Yeah, just that, 2k. Right, and what is the derivative of x squared? 2x, so I've done the derivative of the first function. I have to multiply it by the second function. Who's still going u's and v's? Plus, write the first function. Oh, there goes my ink. And times it by the derivative of the second function. Uh-oh, what's the derivative of e to the x? E to the x. What are we going to do now? Common factor. Right, we've got a common factor of e to the x, so we will yank that out. And what goes in the bracket? We've got 2k plus 2x plus, Oh, what's there? K times K, so I'm going to go K squared, take K, plus 2KX, plus X squared, oof. Keeping an eye on what you're trying to get to. All right, what have I got? I've got K squared, I've got 2K, take K, so that's plus K. I've got, let's put my my x's together. I've got 2x plus 2kx. And I've got plus x squared. This is looking pretty good. Is it not? Pull out my common factor of k here. What am I going to do to get this? Yeah, pull out the x and pull out the 2. And hello, that's it. So we've got last year's exam question, so 2022 P1. Personally, I'm going, ooh, is my first term 1 or is it 1 plus 1 over x? So I can either leave a gap or instead of starting with left-hand side, I go right-hand side. Yeah, so x, 1 plus 1 is 2, take 1 all over x. X take 1. Okay, so we've already had a couple of people go, but we can't make x equal to 1. Remember, we're making n equal to 1, not x, n. So that then tells me my left-hand side, it is not just going to be 1 as my first term. Ooh, that looks a bit ugly. Plus positive integer plus 1 on x. So what I was saying, girls, is that I don't know if my first term is just going to be 1 or if it's going to be 1 plus 1 over x. Now, when we're looking at this, I go, ooh, that's still not going to be this. But then it makes me look and go, oh, hang on, what do I notice on the top line here? Difference of 2 squares. So that becomes x take 1, x plus 1. So never get locked into something. Always go, yeah, I'll put something down on paper. Don't expect to see it when you look at it first up. So now the x take 1's cancel, and I'm left with x plus 1 all over x. You can do one of 2 things here. You can split this up now and go, well, I know that this is the same as x over x plus 1 over x, which becomes 1 plus 1 over x, aka your left-hand side. Or, if you're my year 10s at the moment, you are rocking the adding algebraic fractions. And we know to get a common denominator, we go 1 times x is x, cross multiply, that becomes x plus 1. Either way you go, left-hand side equals right-hand side, and therefore P1 is true. But I would imagine that stuffed up some students last year. Nothing to do with induction, everything to do with just basic algebra. Because, hang on, so we're looking at our first term, right? It's going to be the 1 plus the 1 on the x. It's not just 1. So, and then your second term will be 1 plus 1 over x plus 1 over x squared. That's all they're saying. It's the whole sum. No, ask away. Now, by the way, people, I would suggest that you're actually listening to one another. So we've got people asking these questions, and they're great questions, but you've got to listen. Yep.
Is the first term of the sum not 1, but it's 0? Because 1 over x is 0 is equal to 1.
Oh, there you go. That could be, yeah.
Because I just did it that way and that way.
Say that loud and proud.
That start with p of 0. Well, no, 0 is the minimum end value of the sum, not 1. And if you make it that, it works.
but positive integer.
0 is a positive integer.
Is it? Is it?
0 is up there, it's 1. Neither positive nor negative. It's 0. Well, isn't there positive 0 and negative 0 though? It approaches 0 from above and below that. Yeah.
Wait. Here, let's. Here we go. Who's on chat? GPT, whatever. But we'll go. Is 0 positive? I know, just Google. I know that. Do you know I've refused to get onto? How can I press enter? I know I have, but I don't want them to get to log on. You have to give them your email, and it's like, no, I'm not giving my email. I'm not giving my. Yeah, I protect my. Even though Medicare released all my details, and Woolworths released my details, and who else? Telstra, no, Optus released my details, you know. Hello. I would say their first term is 1 plus 1 over x.
It looks so nice when you do it. It's very simple.
So, but we're looking at your first term would be this, and then your second term, right? Your second, when n is, that's that whole thing there, and then the third one will be that included with that. Deal with it. Let's move on. So,
It's the other way around, though. Is it? Yeah, the first one's the sub on, second one's product. Yeah, I've been doing all my
what's he saying?
You know how there's the
Sigma. You're saying that's product. Oh, Lord, Brody. That's sigma, and that is sum. And then your capital pi is product. Capital pi. Shh. Anyway, let's carry on. So no real maths done, we're just subbing. Now we've subbed in, and don't forget using PK. No. That was, do we have to write QED and everything? And I just said no. Okay, so using PK. Now, what we want to do is get a common denominator. Whether we look at the right-hand side or not, we should see what is the lowest common denominator that we get. And it's x k plus 1, because x k to the k will go into x to the k plus 1, and then x take 1. So just looking at the denominators, we should see that. But if you couldn't, then go and look at, and that gives you the heads up. So now you're asking yourself the big question. What did I times this by, this denominator by, to get x to the k plus 1, x take 1? Didn't we times that by x? So what I do to the bottom, I have to do to the top. So now I get, and I'm going to write, I'm going to say x times x to the k plus 1 times, do you guys want to use brackets, or can I just write, if I could just write x times minus 1 is x. And then what did I do on the right, the right term? What did I times this by to get to that denominator? I had to times it by x take 1. So what I do to the bottom, I have to do to the top. So plus x take 1. Okay, and now we're going to tidy up and hope like fun, that we get, oops, oh dear, what did I do? No. Fun that we get our right hand side. Okay. So this becomes, that's a 1 there, so I've got x to the k, oops, I already wrote x. Did it work, Tom? Oh, good chap. X plus 2 minus x plus x, thank goodness, they cancel out. If they didn't, I'd just go back and check my positives and negatives. Minus 1 and x take 1. Huzzah! Therefore, pk plus 1 is true. Put your statement, all good. You're looking at your first expression, right? We're saying hence, right? Got 1 plus 1 over x plus 1 over x squared. And now this is 1 plus 1 over 11 plus 1 over 11 squared. What's the big thing that you're going to do? You're going to say that x equals 11. Okay, and it still goes up to n. So we go, don't know where this is going. So let's go back up. And we go here and we're going to go x 11. What was it? N plus 1. Take 1.